with the case. I will create the scenario. Then we will go to the analysis, right? Then we will go to the analysis, and obviously analysis would remain same for everyone, right? So this is the thing that we are going to do. So first I am sharing the case. Uh, this case will be shared with you. So I am taking only the relevant part that we are going to use in regression analysis. Okay. Right. So we will start.
We will, sir, one more announcement. So we will take questions and queries in the before break, 5 minutes at the time of break.
Otherwise, Dr. Dharmen, you can unmute them. There's no issue, right?
Yeah. Actually, some disturbance is there. If anyone started to, asking question, then it will be little bit difficult.
Right. No issue.
But we will allow them to in the last of the session.
Okay. And you can write the question and
in the chat box
accordingly.
They can write in the chat box. I will, read that questions. So please continue, sir.
There is some issue with the sound. I think network is quite good at my side, right?
Yes, sir. Yes, sir.
Definitely, I will explain what the regression is. So kindly have patience. Then we will start the analysis. Okay.
Yes, sure, sir.
So first, I am sharing the case. One moment. I should close one or two windows. Right. So. Okay. So this is the case. This case is related to a very popular product, that is baby diapers. Scenario is there have been two major players. One is Procter and Gamble that produces Pampers, and other is Kimberly-Clark that manufactures Huggies. So this case is in between the trade war in between two giants in the FMCG sector. One is Procter and Gamble with the product Pampers, and other is Kimberly-Clark with the product Huggies. Okay. And initially it is related to the history and how the trade war has been there. We are having this scenario from this part only. So I am sharing the relevant part. This part is from in the increasingly competitive diaper market. Procter & Gamble marketing department wanted to formulate an approach to the construction and marketing of Pampers to position them effectively against Huggies. Right. So this was the task. For that, they have surveyed 300 mothers of infant. So they are our respondent, is 300 mothers of the infant, since they are giving us the feedback. So each mother has been given a randomly selected brand of diaper and asked to rate the diaper on 9 attributes. So the first thing that to be noticed is rate the 9 diapers, right? The important word is rate, and also to give her overall preference for the brand. So we have total 10 variables or 10 things under consideration. One, there are 9 attributes that I will introduce later on. And the other side, we have overall preference of the brand. Further, preference was obtained on a 7-point Likert scale. The important word that I have mentioned is rate, and the second word is scale, right? So scale is 1 where not at all preferred, and 7 is greatly preferred. In the same manner, diaper ratings on the 9 attributes were also on the 7-point scale, where 1 is very unfavorable, means not at all liking, and 7 is favorable, right? And these are the 9 diaper attributes that will be there in the data sheet also. The first is count per box, second is price. So they are the diaper attributes are there, right? So the goal or the purpose of the analysis is the goal of the study was to learn which attribute of the diaper was most important in influencing purchase preference. So the important word that should be noticed is influencing purchase preference. Influencing means some sort of relationship has been explored, right? So this is the important word, influencing purchase preference means purchase preference is our important variable. And these are the 9 diaper attributes. So hope the case is clear to all. I'm just checking the chat option. Okay. Right. So this is the scenario. And now I am introducing the case. It means the data set. And this is our data set. The first variable is the preference, right? If we follow the variable, the first is the preference. This is the preference, right? And we have 9 diaper attributes. These are the 9 diaper attributes. There are 2 additional attributes. One is gender of the child and location that we will take in later on. Means today's lecture is not concerned with these 2 attributes. We are primarily concerned with these 10 attributes. One is preference, and the next one are these 9 diaper attributes. So this is the case, this is the scenario that we are going to discuss. Okay, so now I am explaining the concept, then we move to the analysis part. Okay, so as you observe, here we have 2 types of variable. One is overall preference. One is overall preference of the diaper. And on the other side, we have 9 diaper attributes. Okay. So these are the 9 diaper attributes that we are going to use. Just one moment. I am putting my video off because there is some network issues, right?
Okay, sir.
Okay. Okay. So here, this is a scenario. We have overall preference of the diaper, and on the other side, we have 9 diaper attributes. Suppose overall preference is expressed by a variable that is y, and we have 9 diaper attributes. They are x1, x2, and x9, right? And the thing that is desired is we want to examine the impact of these 9 diaper attributes on the overall preference. Means a sort of relationship has been visualized, that there is a relationship between these 9 diaper attributes and overall preference. Okay, so a relationship has been visualized, right? And as you observe here, the word used was rated on a scale, right? The word used was rate on a scale. And here also we have 9 diaper attributes. They are also rated on a scale. So when we use the word like rate or scale, this simply means that we are following some type of scale or the metric variable. So the things are clear that here we are using this type of variable, that is, right, they are rate on the scale, means they are metric in nature. they are metric in nature. And on the other side, they are also metric in nature. So as you know, here the thing is, number one, y is a single variable. So since the direction of the relationship is from these 9 diaper attributes to overall preference, so we can say that the relationship is actually dependence in nature. So the relationship is dependence in nature. And this dependence relationship is unidirectional. Means the direction of the relationship is from x1, x2, x9 to y. Right? So the thing that we observe that the dependent variable is single, and these variables may be termed as independent variables or predictors. They may be termed as independent variables or predictors. Okay. Right. So this is the scenario. Right. This is the scenario. This scenario is used for the regression analysis. Right? So as someone has asked, what do we mean by regression analysis? So regression analysis is a type of relationship study, right? It's a type of relationship study where we have single dependent variable, means we are considering relationship study. We are considering relationship study, and in this relationship study, we have single dependent variable, right? Here we have single dependent variable and multiple independent variable. And we have multiple independent variable. Single dependent variable, and on the other side we have multiple. One moment. Okay. There is some issue with my whiteboard, so I am using this pen only. So we have single dependent variable and we have multiple independent variables. So on the other side, we have single, multiple independent variable. Okay, so this is the case that we are going to use. We have single dependent variable, and other side we have multiple independent variables. So this is a scenario for the regression analysis. Means we want to study some sort of relationship. It is a very popular, very common technique, very useful technique. In most of the situation, we employ relationship, means there are some factors, they are termed as uh, independent variable, and these independent variables may have some impact on the dependent variable. Like in here, in this case, we have 9 diaper attributes. We want to examine which diaper attributes is having some impact on the overall preference. There are n number of examples. Like suppose a particular producer wants to examine why the movies has been hit. So the hitting of a movie or having a wide business, having a broad business is the dependent variable. An independent variable may be presence of actors, actresses, as good music, good direction, good cinematography. So these are the independent variables. These independent variables may have some impact on overall likeliness of the uh, movie. In the same manner, suppose we want to examine the impact of certain medicines, certain tonics, or certain vitamins on the health of the kids. So health of the kid, that can be measured by different factors, different variables, is the dependent variable. And the amount that is taken in the form of different tonics, different vitamins, different carbohydrates are the independent variable. So we want to examine what is the impact of those independent variables upon the health of the kids. So, so hope the application of regression is clear to all. Any question related to regression? Or should we move for the analysis? Since some of you have asked what is the regression analysis, what is the use of regression analysis, right? So hope the things are clear to all.
Yes, sir. We can move.
Okay, right. So now I am sharing the data. There is one more question. Okay. The question is related to, yes, it is related. It is related. It may be in any direction. Suppose you have taken a predictor as the price, right? So price is a predictor, and on the Y, on the dependent, we have sales of the object. So as we know, if price increase, right, then sales may decrease. So obviously the relationship will be in the opposite direction. So we are considering only the relationship or only the dependence. We are not considering the direction. If relationship is there, if direction is there, then obviously it may be in the opposite direction only, right? Next question is independent variable. Independent variables means the variables on which we have control. They are also known as predictor or explanatory variable. Dependent variable are the variable that are dependent upon certain variable. They are the explained variable. Means health of a kid is the dependent variable, and the amount of different vitamins, carbohydrates are the independent variable. The next question is univariate and multivariate. In univariate, we have only two variables, one dependent variable and single independent variable. In multivariate regression, we have one dependent variable and a multiple means more than one independent variable. The concept of univariate and multivariate data is useful for all, right? Regression is a type of association technique, as some of you have mentioned related to chi-square test. Chi-square test is used when we have non-metric data. Non-metric data means data may be ordinal in nature, data may be nominal or non-metric in nature. So as I've already mentioned that the initial condition for regression is our data should be metric in nature. Metric means it is on the ratio scale where we consider the exact, or on the interval scale like 1 to 5, 1 to 7, 1 to 9. Okay. In most, if we have means suppose we want to examine impact of price on sales, then this is the case of univariate. Okay, right. And in the same when we have single variable, but in most of the situation when we are going for the real life study, obviously the regression is multiple regression. That's why we consider multiple regression. So actually univariate regression can be considered as a particular part of the multivariate regression. Bivariate regression is the other name of univariate regression. Bivariate means, bivariate analysis means two variables. And related to correlation, we will discuss during the analysis. The question is, what is ordinal data and nominal data? Nominal data means where we use numbers just for the nomenclature purpose, right? And ordinal data where we consider the ranking scale, means where the ranks have been given. So that is known as ordinal data. Okay. So should I move forward?
Yes, sir.
Okay. So this is a scenario, and here we are having our data set. So this is the data set, and it is an obviously this analysis, regression analysis can be done using any software, and we are using here SPSS. As we know, all the analytical tools are there in the analyze portion. So we will go to analyze, right? And then we go to regression. As you observed here, all the variables x1, x2 are linear in nature. So the most basic regression or the most common regression is the linear regression. So here we are having linear regression. So this is the dialog box of linear regression. Right? This is the dialog box. Right? Here in the left part, we have input pan where we have all the variables, and these variables may be transferred to the right pan, which are used for the analysis purpose. So as we have discussed, we have mentioned that brand preference is the dependent variable. So this is the brand preference, which is a dependent variable, and these are the 9 diaper attributes. They are the independent variable. So these are the 9 diaper attributes which works as independent variable. So these independent variables has been entered simultaneously in the independent list. As you have asked related to bivariate case or simple regression, and other is multiple regression, the dialog box remaining the same. The condition is dependent variable for any regression analysis should be single. So here the single dependent variable. You can enter individual or the single independent variable, or you can enter more than one variable also. Every other thing remaining the same. So as I have mentioned that in most of the practical scenario, our predictor or independent variables are more than one. So that's the reason the single box is given, a single dialog box is given for the regression analysis. So this is a scenario. Here, a number of regression analysis cases are possible. The most common method is enter method. The enter method means all the variables have been entered simultaneously, means all the variables has entered at once only. This is not the only regression. There are a number of other regression methods are available also. One is stepwise method. Suppose you have some prior information that some particular variables are going to be affecting more. So in that scenario, we enter 3 or 4 variables as a first step. Then we can enter some more predictors in the second step and so on. In the same method, remove method means once you enter all the variables, you can remove some of the variables from the analysis. Forward means when we apply the forward method, then software enter variables one by one. The most important variable as per its analysis is entered as a forward. Right? In the same manner, all the variables have been entered, but data repeated in as the number of predictors are there. Backward method means all the variables have been entered, then the least affecting method is deleted first and so on. So these are the different methods, but the most popular, most common, or the most starting method that we start is the enter method. So this is the enter method. So this way data has been entered. And now we will give certain commands related to this button. So this is the statistics button. As you observe, this is a sub dialog box. Certain things are entered. One is estimate. Estimate has been ticked. Model fit has been ticked. We will discuss what do we mean by estimate and what do we mean by model fit. Next is R-square change. R-square change is normally employed when we are using stepwise method or forward or backward method. Since we are doing analysis for once only, so R-square change is not required in this scenario. Next is descriptive. Descriptive means where measures of central tendency, dispersion, different correlation values will be there. There are certain more commands. These commands will be used to check the assumptions. Right? So I will make it clear when we discuss the assumption, then we will mention what is the role of these commands, right? So just have patience till we discuss the assumptions. Here we have also introduced part and partial correlation that will be used to check a particular assumptions. Collinearity is also used for to check a particular assumption. Durbin-Watson is used to check some other assumption. So these are entered in the statistics part. Next is the plot. In plot, some plotting will be done to check some other assumption. So here we use Z residual in the Y and Z predicted in the X, right? So Z residual has been entered in the Y axis and Z predicted has been entered in the X axis. We will discuss what this graph gives us. And we also introduce these two things. One is histogram and other is normality plots, right? So all these things will be discussed when we have the assumptions checking. So we will continue. And the safe part. Here we tick two options. One is predicted value unstandardized and other is residual, that is also unstandardized. This is not required at your level. I am just using it to explain something. Means how predicted values and how residual values are playing some role in our discussion. So these are the certain commands that we have entered. So any question related to these commands? Any question related to this command?
You can write in the chat box.
Assumptions we discussed, so don't bother about the assumptions. Yes, the question is multivariate. Multivariate, the bifurcation is, the first is univariate, single variable. Bivariate means we have two variables. Multivariate means we have more than two variables. Then obviously it belongs to the multivariate data analysis. I will explain what we mean by predicted and residual value, so have patience. What is block 1 of 1? Block 1 of 1 is used when we are using stepwise method or the removal method. The block 1 is the first block of variable that is entered at the step 1. Block 2 is the second step when we are entering some more variables. What is collarity? I will explain when I explain the assumptions. Please repeat the meaning of word in statistics. It is not very clear. Right. The condition for the regression analysis is dependent variable must be 1. Okay. No, it is not related to post hoc. And forward method is a method where single independent variable is entered at every stage. Stepwise method means, suppose among these 9 predictors, suppose you consider count, price, and value. As per your perception, they are the most important variable, just for the example. So as the first step, you enter these 3 variables only. So it is the step 1 or block 1. And in the second step, we can increase some more predictors like absorbency, leakage, and so on. R square, I will explain. Forward method is different. In stepwise method, we enter variable on our own. But in forward method, software or the regression analysis itself chooses the most affecting variable, the most important variable, and so on. So in forward method, we don't have any control upon the sequence of the variable. Okay. So forward method and step methods are clear. No, it is not necessary to perform univariate analysis. Actually, in statistics, we do mention that when we consider single variable, then the interaction effect can never be examined. So whenever you have more than one predictor, it is always recommended that all predictors should be used. The question is selection variable. So as I will explain, the selection variable is, suppose this diaper is to be sold in a particular location only, right? We have 3 locations, 1 metro, 2 big cities, 3 towns. Suppose we want to sell this product in metro only. So we want to use data set from a particular location that is metro only. So in that scenario, we enter location as the selection variable and give the code of location. Suppose the code of the location is 1. So we will enter 1. Means in that scenario, this analysis will be run only for those cases which belongs to a particular location. So when I share the data, then you can replicate this analysis for a particular set also, right? In the same manner, suppose this product is to be sold for a particular gender. So it is no point to do analysis for both the genders. So in that scenario, only one gender is used as a selection variable. Okay, so this is the role of selection variable. At present, we are running the analysis on all 300 observations. Binary means there are two variables, single independent and single dependent. Okay, simple regression. Multivariate means we have more than two variables, single dependent and more than one independent variable. Should we use any criteria for variables to be used? Yes, it depends upon the exploratory factor analysis. Sorry, it depends upon the exploratory design. Suppose in past you have performed this analysis, or you have some document or the research paper in your support. So as per that research paper, you can use the criteria. In one, no, chi-square test is primary, is the chi-square is when you study the chi-square test is based upon counting, right? As we know, we use the option of counting only when we have non-metric variable, right? Means suppose we want to examine whether gender is having some impact upon likeliness or dislikeliness. So in that case, we have nominal data. So chi-square test is recommended for nominal data only. Right, so that's the reason we move beyond chi-square test. So it is not necessary that we should use chi-square test first, then we use the regression. Okay. Any other question?
So I think so.
The variable should be, yes, variable should be quantitative. Quantitative is simply means it is metric in nature. Independent variable and dependent variable again. Miss Subhashri, which particular field you want I should take the example? You can mention the field. I will take example from that field only. Medical. Okay. So independent variable means, suppose the most rudimentary example I am taking. Suppose you want to examine the impact of a drug, right, on health of a particular person. Suppose health is measured as per some standard. Okay, so health of that person is the dependent variable, and the amount of drug that is administered in that patient or that person is the independent variable. Okay, right? Some more example. Uh, Suppose you want to examine the relationship between amount of carbohydrate and the weight achieved by a person. So amount of carbohydrate is the independent variable or the predictor, and the weight gain is the dependent variable. Okay. Any other question? Okay. Since sorry. So obviously all these cases belongs to a particular field only, right? But the analysis or the concept of statistics, the type of data. Primarily, we have two type of data. One is metric. Metric means which is measured, right? And the other one is non-metric. Non-metric means which is not measured, which is categorical in nature, right? So these are the two broad bifurcation of type of data. Related to scale, we use four type of scale. The first one is the nominal scale. Nominal scale means, as you remember, the short number of Saurav Ganguly is 99. So 99 is a number, but that 99 is not measuring anything. Suppose the room number suppose the room number of your class is 102. So 102 is a number, but 102 is not measuring anything. In that scenario, number is used only for the nomenclature purpose, right? Like here, we use code 1 to represent male and code 2 to represent female. So they are the numbers, but 1 and 2 are not measuring anything, right? 1 and 2 are just the nomenclature or they are representing anything. In the same manner, in location, 1 is used for metro, 2 for big cities, and 3 for the towns. So they are not measuring anything. They are just representing thing. But here, the tapping. Here, 1 is least preference, 7 is the most preference. So there is some ordering, right? Just like an scale. In scale, 2 is always greater than 1 or 2 is always less than 1. But in non-metric data, they have no such role. Correlation is a part of regression analysis, right? So correlation is used to examine the strength of the relationship. So question is not among whether we should use regression or we should use correlation. Regression is a broad analysis which consider dependence relationship. Correlation is relatively minor in nature, which consider only the relationship. Can we attribute number to HB? Okay, if you bifurcate the data related to HB means higher than 6.5 or lower than 6.5, so that become categorical. But if you take exact amount of HB, means 6.5, 7.5, 9.9, 10, 14.2, so that become metric in nature. Okay. Case labels simply means when we put here the cases name is 1, 2, 3. They are unknown people. But suppose you want to put the name, right? Means case number 1 belongs to Masood, case number 2 belongs to Himanshu, case number 3 belongs to Ashish, case number 4 belongs to Dr. Sanjeev, right? So in that case, cases will be used. So in that scenario, output will be, means the values would be accordingly as per the name also. Measurement. So this is not related to this case, measurement of central tendency. Okay, the question is interesting one. Yes, you can use chi-square test, but definitely scale gives us more information. Just like example, suppose for a particular person, you know that a particular person has secured first division, right? So this is a non-metric data. In that scenario, you can use chi-square. But if we know the exact percentage, suppose that person has 76% as the score. So 76% can always be converted into first division, but first division cannot be converted into 76%. So obviously, if we use metric data, it gives us more information. Since it gives us more information, so it is better for the analysis and it gives more about those variables. So obviously we can always convert metric data into the non-metric data, but in that scenario, there is some loss of the data. So it is not at all recommended that we should convert our metric data into non-metric data, right? So in all those scenarios where regression is possible, then we should not attempt non-metric association technique like chi-square. Okay. So Mr. Suren, is it clear? Okay. WLS weight are those weights, right? Here we are considering equal amount since we are using linear regression using OLS estimation. When we use some other technique like generalized estimation, then we put different weights to different people. So in that scenario, we will use WLS weight. If we have data with yes and no, then that is non-metric data, right? Then in that scenario, we have to use chi-square test. Independent parameters can be anyone, right? Here we are using 9. So we can use 1, 2, 3, 4, 5, 9, 20, 21. Any number of predictors or independent variables can be used. There is no limitation. Okay. Any other question? Okay, so should we move forward?
Yes, sir.
Okay. Right. So this is the scenario, right? Tailed data means?
It is. I think he is talking about one-tailed and two-tailed. So
that is the analysis. One it is not data. It is
Yeah.
type of the test that is employed. Means
Yes.
whether we are considering uh, uh, whether we are considering not equal to in the H1 or we are considering greater than or less than.
Type
Right?
of hypothesis actually.
Type of hypothesis, right? It is
Yes.
not related to data.
Yes. Yes.
What chi-square tells? Chi-square tells us the association.
Association between attributes.
Right.
So okay, sir.
They are the non-metric data.
Yeah. Yeah.
Okay. Okay. Should we move forward?
Yes, sir. Sure.
Can we have odd? Odds are used when we perform logistic regression.
Yeah,
Odds are not
we will.
odds
Yeah,
are
sir.
not used in the regression analysis.
Sir,
So
we
when
will.
we cover
Hmm.
logistic regression, then I will explain odds.
Yes,
Okay.
sure. Sure, sir.
So this is the case, and we put okay. So I'm sharing the output. Okay, so this is the output. Okay, the output is there.
Yes, sir.
Okay, there are some question in the chat. We will take right.
Yes, after that.
Okay, one is if we have agree, fully agree or disagree, right? Then what type of test should be employed, right? Here we have agree. Since we are giving it a scale, right? If we are giving a scale, so means strongly agree, right? Agree, neutral, disagree, strongly agree. So this is an scale. So as we develop a scale, then obviously regression can be employed. But if we have two broad categories without common difference, right? In that scenario, we should use non-metric data. Case label I have explained. Case label simply means we put the name as the case. As you observe the data when I share the data file, there is no name in the cases. Cases means the respondent, right? So if we put name of the mother as the first variable, then if we put the case label option, then all the predicted value will be there as per the name of the mother. And weights means when we perform the regression analysis, the method uses ordinary least square method, right? Ordinary least square method that I will explain minimizes the square of the difference between observed value and the predicted value, right? So in that scenario, we give equal importance to all the observations, right? We take equal weights. So in that scenario, we don't use the weight label. But suppose we want OLS is not applicable in that case. So in that scenario, we use different weights for the analysis. So that is the weight option. Logistic regression, when I cover logistic regression, then I will explain the difference between linear regression and logistic regression. Okay. Right. So this is the scenario. Now I'm sharing the concept again. Okay. So just like any relationship study, suppose we want to study relationship. Since regression is a linear relationship study, so I will first explain what are the essential steps of any relationship study. You can compare it with any real life scenario. Suppose a task that is given to you is you should examine relationship between two persons. So the first question that you examine, whether there is a relationship or not, whether there is relationship or not. Okay, right. Obviously here we have two answers. One is yes, right? And the second answer is no, right? If answer is yes, we will move forward. If answer is no, we don't move forward. In the when we consider the regression, right? Regression is just the modeling of the relationship. So we use the term, we examine significance of relationship. We examine significance of the regression model or significance of the relationship. So this will be our first step. So if in case yes, we will move forward. If we know, obviously y is affected by some variables. If these variables are not affecting our y, then no means we should look for some other predictors. Look for some other predictors, right? Just like in the case of medical data, right? Suppose you tried a particular medicine. Medicine is not having an impact, or medicine is not uh, uh, limiting the disease, then we look for some other medicine. In the same manner, if relationship is not in between these variables, then we will look for some other uh, variables. Obviously, in this case, our answer would be yes, right? So here we will explain, we will go for significance of the relationship. So this will be our first step. Second, we move beyond yes. So the second point is we consider strength of the relationship. Strength of relationship. Just like in a real life, you may be related to more than one person, but your level of dependence is not same every year. So we consider strength of the relationship. In the language of regression, we say we examine strength of the regression model. We will discuss what are the parameters for that. Strength of the regression model. So this will be our second step. The third step, right? As we say that for relationship, it is not necessary that all 36 or 63 properties should match. सब 36 गुणों का मिलना जरूरी नहीं होता है. As we say that only some important things like compatibility, right? Socio-economic compatibility, compatibility of nature, openness can govern the relationship. Means we examine what are the essential reasons for the relationship. What are the essential reasons for the relationship? This will do in the real life analysis. Essential reasons for relationship. In the language of regression, we look for what are the important or influencing predictors. What are the important or influencing predictors? So this will be our third step. Now, the fourth step. Suppose the relationship is because of more than one reasons. The number one is compatibility. Number two, they work together. Number three, they travel together. Then obviously you may be interested, what is the most important reason among these three? Means you create hierarchy of these reasons. You create hierarchy of the reason. Here we create hierarchy of this influencing predictor, right? Means which predictor is having the most impact. So that will be taken up. And the last, since we propose a model, Okay, one moment. Probably that is deleted. Right, this is there. Right. The next step is, okay, since this is a model, so in the fifth step, we propose a predictive model. This predictive model will be used for the future purpose. And here I will explain what do we mean by predicted value. So these are the 5 steps that we essentially discuss. There is one more step that I purposely have not discussed, but this may be an important step, is checking assumptions. Checking assumptions. So this will be termed as 0th step. For a particular reason, to show you something, I am not taking this step as the first step. So that's why I have mentioned the step as 0th step. So this is the 0th step that we will discuss later on. So any question related to these steps? Right. So these are the 5 stages in the analysis, and after the 5, I will check the assumptions only. So our regression analysis consists of the discussion related to these 5 steps. Means any research paper, any report for any analysis, these 5 steps should be covered in that analysis if we are doing regression analysis, or even if we are doing some other relationship study like logistic regression, probit regression, and etc. Any question related to these points? These 5 stages. Fitness we will discuss. Right? Hierarchy. Hierarchy means, suppose you have identified that related to health, number 1, exercise is having some impact. Number 2, proteins are having some impact. Number 3, some particular vitamin is having some impact. Right? Suppose you can't control all 3, but suppose you cannot have access to all 3. So you obviously you are interested to know which one is having the most important impact. Like in this scenario, in this case, we have 9 predictors, right? We have 9 diaper attributes. So hierarchy means which attributes is having the most important role in the preference. Okay. Step 5 is we propose the regression model. I will explain. Okay. Strength and significance I will explain during the analysis. Checking of assumptions. Checking of assumptions means any analysis has performed by taking certain assumptions, right? So these assumptions must be fulfilled. So this concept is checking assumption. Purposely, I am not using this step as the first step, just to show you, just to establish the role of assumptions. Okay. Any other question? Basic difference. There is no difference actually. I have taken a real life example, a very common example जो हम लोग सबके साथ होता है, in the heading relationship, and these things are converted into the technical term that is the regression analysis. So they are actually the same, just to establish how regression is applicable in our daily life also. We examine our relationship as some type of regression analysis also. So this is the thing. Can you explain the relationship yes, no with an example? If we use yes, no, then obviously the data would be non-metric in nature. Then in that scenario, regression can't be used. Okay. Right? That is the case for the logistic regression when we have dependent non-metric variable. Okay. Okay, Mr. Pradeep. Any other question? Okay, right. So, no. Again, Mr. Suren, odd ratio doesn't come in regression analysis, right?
We'll
Okay.
cover in the logistic regression.
Logistic regression. So odds are not there. I will mention what are the parameters, right? So my question is whether these 5 steps looks logical, right? Chemistry. Suppose dependent variable is amount of precipitation and the independent variable is the strength of the acid used. So strength of the acid is the independent variable and amount of precipitation is the dependent variable. We can, if we have both dependent, non-metric and metric, since dependent variable is single, so how can dependent variable is both non-metric and metric? The dependent variable is either non-metric or single, right? As we have mentioned, a dependent variable is single only, right? So single variable can be either non-metric or metric. It can't be both. Yes, independent variable can be both independent variable and as well as dependent variable. So if we, metric variable as well as non-metric variable. So if we have non-metric independent variable, then non-metric variable independent variable should be converted into metric variable using dummy variable. So dummy variable regression is also a type of regression. What is the purpose of doing linear regression conditions? They are used to check assumptions. Okay. Fine. Okay, now I will explain the concept of the model, right? As concept of the model. As in this case, we have y as the dependent variable, and on the other side we have independent variable as x1, x2, x9, right? And now I am proposing the linear regression model. Okay, so this linear regression model, right? Just I am taking the example of straight line example, right? In the coordinate geometry, right? You must have studied the straight line equation. The straight line equation is typically expressed as y is equal to mx plus c, where x is the x-axis and here we have y-axis, right? Okay, so this y is equal to mx plus c can also be written as c is equal to y is equal to c plus mx. I have just changed the position. Here c is the intercept, which is c. So c is a constant, right? And m is the slope. Okay, slope means rate of change. So m is actually delta y over delta x, change in y with respect. So this is the typical equation of a straight line. So same concept is used when we consider linear regression. So if we are considering bivariate regression or simple regression, right? So bivariate regression means we have single dependent variable and single independent variable. So in that case, it can be written as y is equal to beta 0 plus beta 1 x, right? Okay, so y is the dependent variable. It is just similar to this equation. These two equations are approximately same. Instead of c, we have used beta 0. Beta 0 is a constant. And instead of m, we have used beta 1. Beta 1 is the slope. So this is known as bivariate regression model, right? So this is the bivariate regression model where we have single independent variable, right? This can be generalized to have multivariate regression model. So it will be y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 up to beta 9 x9, right? Okay, right? So this is just an extension of bivariate regression, or in other words, bivariate regression is a particular case of multivariate regression where we have single independent variable. Both models are same. As you observe here, all the regression coefficient beta 0, beta 1, beta 9 are single degree. So they are linear in nature. So this is our regression part. So obviously these variables are included in our study. So this is known as explain part. This is known as explain part or the regression part, right? But along with these 9 variables, as we know that preference may be affected by these 9 only, it may be affected by some other variables also. As you observe those 9 predictors, those 9 variables, some variables are not there, like packaging is not there, advertisement is not there, peer recommendation is not there, right? There are some variables which are not included. So since there must be some other variables which may not figure in our regression model. So they are known as unexplained part. Unexplained means they are not considered in the model. So they are also termed as the residual part or extraneous part. Extraneous means they are extraneous to the model, right? Sir, right. Just like the performance, health performance or the response to a drug of a patient does not depend upon only the chemicals that are used in drug. There are some additional factors which may not considered in that study. Means additional factor can be some previous disease, his or her lifestyle, right? His or her certain different conditions which are not taken up in those models. So they belongs to the residual part or the error term. So this model is known as multivariate or multiple regression model. This is our proposed model that we are going to consider, that we are going to study, right? So during the analysis, we will figure out the values of beta 0, beta 1, beta 2, beta 9. They are the regression coefficient. Here beta 0 is constant, right? Beta 1 is termed as regression coefficient of y on x1, right? Like here we have beta 1 is the slope, or beta 1 is the regression coefficient of y on x. So what is the meaning of this term? It gives rate of change. It gives rate of change in y with respect to x1, provided all other predictors remains constant, right? Suppose in this case, suppose here we have y as preference, right? Suppose x1 is the rating given to count, right? And beta comes out to be, suppose 0.5. So 0.5 means 0.5 is actually delta y over delta x1. Means if we make unit change in the rating of the count, then our preference will change by 0.5. Here, the sign may be positive. If the sign is positive, we have direct relationship. If sign is negative, we have inverse relationship. Means if there is positive 0.5, then on increasing x1, y will increase by 0.5. And if we have minus 0.5, means if we increase count rating or x1 by 1 unit, there will be a decrease of 0.5 in y. So these are the importance of the sign. And here the condition is provided all other things remaining the same. So technically they are known as partial regression coefficient, because here other factors has not been considered. Okay, so this is our proposed model. So any question related to the model? Any question related to the model? Any question?
You can write in the chat box.
Partial regression, not partial correlation. And the question is, last example again, x1. What is x1? Okay, right. Here, as I am showing you the data file, sorry, the variables, right? Here, y is the overall preference, right? As you see, x1 is the rating given to count. Means the person is how much satisfied with the count per box. So this is x1 variable. So count per box is represented by x1, right? So these are our independent variables. So x1 is just the representation of the first variable. Okay. No, you can't use logistic regression in place of linear regression. I will explain when I explain logistic regression. Logistic regression is an inferior technique as compared to linear regression. Okay. So logistic regression should be used only in those scenarios where regression is not possible. Okay. What is beta 1? Beta 1 is the regression coefficient. It is actually the rate of change in y with respect to x. Means if we make 1 unit change in x1, then what is the change in y? And why it is termed as beta 1? So beta 1 is related to x1. In the same manner, beta 2 is related to x2, beta 3 is related to x3. All those explanations are same. Right? Just for example, I am taking an example from here. Suppose there are two vitamins, x1 and x2, right? Suppose this is vitamin x1 and this is vitamin x2. And you are considering their impact upon weight gain or impact upon strength. Suppose here x1 regression coefficient of x1 is 2.0 and regression coefficient of x2 is 1.5. It means if we increase x1, if we increase the dose of vitamin x1, the health standard will increase by an amount of 2.0. So this is the role of beta 1, right? Provided x2 impact remaining the same. In the same manner, when we consider x2 and the value beta 2 is 1.5, means if we make unit change in the dose of x2, the health standard will increase by an amount of 1.5. So if you want to choose only one of these two vitamins, suppose only one vitamin is to be given, then obviously you will go for x1 because it have higher impact on the health standard. Okay. Residual I will explain. Okay. Any other question? How come slope changes? Slope actually represents the impact of that predictor on the dependent variable. So obviously, since we are considering a number of predictors and all the predictors are having different impact, so they have different regression coefficient. So that's why we don't use the word slope. I use the word slope just to make connection with the coordinate geometry. Since coordinate geometry we all have studied, so that's why. can we combine x1? Yes, we can combine an x1 and x2, but if we combine x1 and x2, then the degree will become, then we consider the interaction effect, right? Since that doesn't come under the linear part. So at present, we are not considering the combined effect of x1 and x2, but obviously they can be combined. Okay. In the risk factor of can, what do you mean by can? In it,
Okay, it's it's something medical terminology.
that I don't know, right? But you can visualize this analysis for anything, right? Means where there are certain predictors, there are certain independent variable. You want to examine the impact of those variable on certain dependent variable on certain condition. Then all those scenario regression can be employed. What is the max? No limit. Okay. What is the minimum value of beta which will identify the effect, right? If it, they are the comparative values only. 2.0 is compared with 1.0. Okay. Any other question? Dr. Sanjeev, I will explain when we perform the analysis, right? Okay. What is the last term? Last term is the residual factor, right? E is the residual factor, means impact of all other variables on Y, right? Like when we consider some medicines or some particular doses, we might there means same amount of vitamins, same amount of carbohydrates are given to two exactly two people, right? But their impact may be different. So obviously those impact is not due to the amount of carbohydrates, vitamins or protein. They may be because of some other thing which are not considered in the model. So is the error term or the residual term or unexplained part which are not considered in the model. Okay. I will give the study material related to regression. Okay. Otherwise, I will share my number. You can ask any question related to regression. Even if a particular data set, we can discuss that case for that particular data set only, right? But it will be individual only. Right? Okay. So we move forward.
Yes, sir, sure. Sir, someone is asking that when do we use the term linear in regression analysis? How do we know?
How do we know? Okay. So here the concept is, there is a concept known as scatter plot. Okay. So okay, there are number of techniques by which we can examine the linearity, right? The first is we can use scatter plot. We can use independent variable on the x-axis and dependent variable on the y-axis, and we plot the point. If points are much closer to a straight line, then we can have the linear regression part. Otherwise, the most common assumption is related to linearity, right? So linearity depend upon type of data only. So there are a number of factors by which linearity may be examined. Some type of interpolation method can also be used to examine whether there is linearity or not, right? And when we check the assumptions, when we consider the residual, then there is one more test I will explain that also take care of the linearity part. Okay.
So can we move further, sir?
Right. There is some more question. Right. Anyway. Okay. So Should we take a break or?
Yeah, sir. We can take the break of 5 or 10 minutes.
Okay, so we take just a small break. It is
7:20, I think.
7:20. So we will meet at 7:25. Okay.
Okay, sir. Sure, sir.
Regression model is null or zero, or in technical word, this is insignificant, right? So this is our proposed regression model, right? Now we will check whether this holds or not. As we have just observed that in Y, there is variation. So this variation is being termed as total variation, right? So there is total variation in our dependent variable Y, right? As you observe, a value is 5, value is 6, value is 3, value is 2, right? Now we try to explore what are the reasons for this variation. And one reason is the variation is because of these predictors, right? Variation is because of these predictors. Since we are considering this predictor, so this type of variation is known as explained variation, right? Means predictor are having impact, and somewhere predictor are high, so the values are high. Somewhere predictor is low, so values are low. Since we are considering it in our model, so this type of variation is known as explained variation. And technically, this type of variation is the variation because of the regression model, right? So this is the variation because of the regression model, right? That I have shown through x1, x2, x9. So this is the explained variation. Along with the explained variation, we also have variation because of some other reason. So this type of variation is known as unexplained variation. This is known as unexplained variation, or variation because of residual, right? Or variation because of extraneous factor, right? So any variation is Y can be bifurcated into explained variation or unexplained variation. Since we are analyzing our variation, so this concept is known as ANOVA, analysis of variation, right? Okay. Now total variation for a particular data set is always remains constant. So if we have high explained variation, then obviously unexplained variation would be low. So if explained variation is high, means the most of the variation is in Y is because of those predictors that we are considering. Means regression model is playing a significant role in that model. So if explained variation is high in a particular scenario, we can say that our regression model is significant in nature, right? In the same manner, in some scenario, if unexplained variation is high, since unexplained variation is high, means variation is primarily because of some extraneous factor, some otherwise factor. And unexplained variation is high means the reason for the variation is beyond the model. Since mainly the variation is beyond the model, then we can say that our regression model is not so good. Our regression model is insignificant in nature. Means these predictors are not having the desired impact, right? So if explained variation is high, then obviously the model would become significant. Now the second question arises, how can we decide which variation can be termed as high and which variation can be termed as low? So we consider a ratio. This ratio is termed as F, or F statistics. It is the ratio of explained variation, or variation because of regression model. So it is the ratio of unexplained variation and unexplained variation and unexplained variation in the denominator. So if we consider the F ratio, so in the first case, when explained variation is much higher as compared to unexplained variation, means numerator is much higher as compared to denominator, then obviously the value of f would be much higher as compared to 1. So if value of f is much higher as compared to 1, it is because of the fact that explained variation are much higher. So in this case, again, we can say that our regression model is significant in nature. But in the reverse case, when explained variation is not higher than unexplained, or explained variation is at near about unexplained only, then in that scenario, f is approximately 1, means f is near to 1. So if it is the case, then obviously the contribution of explained variation is not so high. So if this is a scenario, then we can say that our regression model is not so significant, means our regression model is insignificant in nature. And these two concepts are related. Now this f is a f statistic. Why this is an statistic? Because it is a random variable. Obviously, this value is dependent upon the sample. If sample changes, then value of f may change. And we can never know beforehand what the value of f is going to be. So this type of variable is known as random variable. And if we plot the probability distribution, the probability curve of this statistic, then we have a distribution known as F distribution, which are available in most of the statistic book. So here we have F statistics on the x-axis, and on the y-axis we have probability of F statistics. And this is the curve. This value f can never be negative, because variation is there. Variation means whole square is there, and variance can never be negative. So the minimum possible value is 2. So this is the curve, and it is its modal value. This modal value is corresponds to the value 1, right? And this is infinity. It goes up to infinity. Suppose this is the case if f is much higher as compared to 1. So if f is much higher as compared to 1, then suppose f comes out to be 100 or f comes out to be 40. So f is much higher to 1 means it is near to the right part. It is near to the right part. So if we consider this part and we consider this area, this right tail area. So this right tail area is actually the p-value for this statistic. This is the p-value for this statistic. Okay, this is the p-value for this statistic. So obviously, if value of f is much higher as compared to 1, value of f is very high, then this area would be low, and accordingly our p-value would be low. And suppose this p-value is less than 0.05, right? Then again we can say that our regression model is significant. Means this is less than 0.05. So for the analysis purpose, for the testing purpose, we are rejecting H0. Rejecting H0 means we are rejecting the insignificance of the regression model. Means regression model becomes significant. So you can consider any concept, whether as per the theory, as per the concept, or you can directly use the value of p-value. In the same manner, suppose f is not much higher as compared to 1. Means suppose value of f is 2. So in this scenario, f would be near to 1. So if we consider this part, right? So here the right tail probability or the right tail area would be very high. So for the second scenario, when f is not that high, f is near about 1, then this right tail probability would be very high. So in this case, the right tail probability, that is the p-value, would be high. And suppose we are considering 5% and its value is greater than 0.05. So since p-value is high, it is because of the fact that value of f is low. If value of f is low means explained variation is not much higher. So in this case, we can say that our proposed regression model is insignificant, or in the language of testing, we can say that we cannot reject the null hypothesis. We have to accept the null hypothesis. We don't have to reject the null hypothesis. So I explain according to both the concepts, right? And I will show you the output also, right? So first I'm showing you the output, then we will take up the questions. So some questions will be covered in that part only. So this is ANOVA. Why we are using ANOVA? Because this is an analysis of variance. As you observe, here the total variation has been bifurcated into two parts. One is explained variation, that is nicknamed as regression. Other is unexplained variation, that is residual, right? Explained variation has the value 93 and 93.491, and the residual is having the value 1. So if you compare 93 with 1, you can easily say that 93 is much higher as compared to 1. Means explained variation is much higher as compared to unexplained variation. This is the first part. Now this is the F statistics. F statistics is the ratio of explained variation and unexplained variation. So 93.491 divided by 1.07, you will get 87.33. So this is the F ratio. So obviously, since explained variation is much higher as compared to unexplained variation, so this value of F is much higher as compared to 1. 87 is much higher as compared to 1. Since this F value is very high, so the P value that is expressed by significance SIG is much low. This is 0.000. 0.000 means there is no value up to the first 3 decimal values. This 0.000 is less than 0.05, means we would reject H0. Right? So you can directly use the significance value. Otherwise, you can use the concept. So both things are similar. So now any question up to this analysis. This is the first part. So we can write that our P value, I'm just writing the output. So here we are writing, here our P value means significance is 0.000. This is not 0. It is simply there is no value up to this point. This value is less than 0.05, means we would reject H0. Reject H0 means we would reject insignificance, means our regression model is significant. Okay. So this is the interpretation of the first step. Right. Dr. Sanjeev, enter means all the predictors have been entered in one go. So this is the enter. Doesn't the null hypothesis means there is no variation? Actually, the null hypothesis simply assume there is no difference, right? So here we are variation will always be there. We want to examine whether this variation is because of the explained part or the unexplained part. So H0 doesn't mean that there is no variation. Variation will always be there. There are formula for calculating explained variation and unexplained variation. All books have the formula, right? Explained variation means sigma yi minus y bar whole square. That is the explained variation. And unexplained is always calculated by total variation minus unexplained. Degrees of freedom are 9. Why there are 9? There are 9 predictors. Fine. And our sample size is 300. So 300 minus 1 is 299. If we subtract 299, if we subtract 9 from 299, we will get 290. What is the interpretation of significant p-value with the example? So p-value is simply the right tail probability. Means this is the extreme value. F is giving an extreme value. So extreme value can never be accepted. They would be rejected. How to calculate p-value? Number one, tables are given. Otherwise, you can easily, when you use Excel, then you put the value of F as that is given 90. Then, and if you press the F inverse, you will have the value of P. And tables are given.
Yeah, sir.
Null hypothesis is highly significant. We simply use whether the hypothesis relationship is significant or insignificant. We don't use highly or moderately insignificant.
Yes, yes. So, so actually, p-value is a concept during the software. Uh, Earlier, it was not
Please,
used for the manual purpose.
Mr. Salim, okay,
Yes.
Mr. Salim, KMO and Bartlett test of sphericity is not used in regression. They are used in factor analysis.
Factor analysis. So we will, when we cover the
Right.
factor analysis, then we will.
Right.
Actually,
The question is,
hmm,
uh, okay. The question is, if it is not significant, then. So if values are not significant, then obviously regression model doesn't hold. Then we look for some other predictors that are having an impact, right? So
we go.
current analysis stop and we look for some other, means again, and the research part again starts. Okay. F is simply the ratio of explained variation and unexplained variation.
Actually, p-value is called for the probability value, and it is nothing only, probability of accepting the null hypothesis under the assumption that it is true. Okay. So as much as p-value will be high, there are, high chance of accepting the null hypothesis. So many times it is said that.
Some question.
Yes, sir.
I am taking some more questions also, right?
Yes, sure.
If f value is 2 or 3 and p value is right, actually when we mentioned that value of f is significantly different from 1, we don't know where the demarcation line is there. So p value simply guides us beyond that value, the significant value start, right? Okay. So the main criteria is using p value only, right? So how the p value has been obtained, then I explain the entire part. Okay. I am showing you the result again. So this is the result. Okay. Why 299? One, and they are the degrees of freedom. 1 degree of freedom have been sacrificed because the total remains the constant. So 399 minus 1 is 299. And sum of regression and residual should be equal to the total. So 9 plus 290 is 299. Why 9? Because we have 9 predictors, right? And how the mean square is calculated? We simply divide sum of square divided by degrees of freedom. 849 divided by 9, we have 93. 310 divided by 290, we have 1.097. Okay. Any other question? So I explained the ANOVA table again. F value, only in the theoretical cases we have f value as 0. In the real life, we never have f value as 0 because there will be variation from both the cases. If we have 9 independent variable, give f value is 5. Okay, the f value is not related to the number of independent variable, right? Since mean square take care of number of independent variable. So whether it is 9, 10 or 5 or 20, the mean square has taken that consideration. So f value is not dependent upon number of, right? It only depends upon the p value is dependent upon the degrees of freedom. 290 is 299 minus 9. A and B are mentioned in the output. A is the dependent variable and B are the predictors. Significance of, it is always done by ANOVA. Mr. Shiv, you are right. Only metric independent variable can be entered. If the independent variable is non-metric in nature, then we have to use dummy variable regression. Means we have to convert non-metric variable into metric variable using dummy variables. Relationship between f. Higher the value of f, lower is the p-value. Lower the value of f, higher is the p-value. Because it simply gives the right tail probabilities. The probability of the extreme points. Extreme values. Dr. Nero, you have to wait for the third step, which has least effect. Is it clear to all? Should we move forward?
Yes, sir.
Okay. Since we have 7:58, I am taking up just the second step, that is related of regression model. No, logistic regression cannot be used in place of W regression. Beta I will explain when I am taking up the point. So if F value and P value are coming out to be 0, Dr. Shushma, so in that case, there is linearity is under the question mark. So if you are getting F value and P value are 0, then it simply shows that linearity is not there. I will explain how the non-metric variable is converted into metric variable. Mr. Suren, ये तो वही बात हो गई पूरी रामायण पढ़ने के बाद आप पूछे, right? When to use regression analysis, right? Degrees of freedom means the mathematical freedom that we have. I take an example. Suppose I ask you, tell me any 5 number. So you have the freedom to choose any 5 number. Means you have full freedom to choose 5 numbers. Suppose I put a condition that tell me any 5 numbers such that their sum is 100. Then obviously you can choose only 4. Right? The 5th number should be such that it completes the sum as 100. So if we now in that case, I have imposed a condition and it decreases the degrees of freedom from 5 to 4. Means 1 degree of freedom has been sacrificed because of the condition imposed. Right? So it is simply give us the amount of mathematical freedom that we have. It is represented by degrees of freedom. It is used in chemistry also when we consider the Brownian motion, means the particles or the molecules have freedom to go in how many directions. So this is simply the degrees of freedom. No, we can't use logistic regression. Logistic regression is used when we have non-metric dependent variable, and dummy variable regression is used when we have non-metric independent variable. Okay, Sarita ji? Is it clear? What is p-value? P-value is the probability value. It is the right tail probability. It simply gives what are the chances of having such an extreme value as that value. So this is the p-value. Okay. Right. So I am explaining one more concept because it is related to this ANOVA only. Right. And now I am taking model summary. There are some questions related to R square, adjusted R square, and so on. I am take questions later on. Right? I am again using my whiteboard. Okay. Now we are going to the second step. The second step is related to strength of the regression model. Right. Here we use the term R square. R square is coefficient of determination. R square is the ratio of explained variation and total variation. Okay. Now, since explained variation is always a part of total variation, so explained variation can never be higher than the total variation. At most, explained variation can be equals to the total variation when unexplained variation is 0. So in this scenario, the maximum possible value of R square is 1, right? On the reverse side, since they are the variation, they are the whole square, so they can never be negative. So the minimum possible value is 0, right? So this is the concept. Suppose I am taking an example. Suppose r square comes out to be 0.90. This 0.90 can be written as 90 upon 100. So if we compare this formula, okay, with r square, right, means here in the case means here the total variation is 100. So out of 100, 90% is the explained variation. Means our model is able to generate 90% of the explained variation. Means if there is a change of 100 in the dependent variable, the 90 is because of the proposed model, right? So this concept is known as, it means here the high percentage of variation has been explained. So obviously this model can be said to be strong. So if values are near to 1, then we can say that our proposed regression model is strong. Suppose in some other scenario, suppose r square is 0.15. So 0.15 can be written as 15 upon 100. Means if total variation is 100, the explained part is 15. So the unexplained part is 85. Here the major dominance is from the unexplained part, and the explained part is not much contributing. Then obviously this is considered as our regression model is low or weak. So if values are near to 0, then we can say that our regression model is weak in nature. So this is the basic concept. But what is the rule of now the issues arises. Suppose a particular person gets r square as 0.62. For a person X, 0.62 can be very high. For some other person, 0.62 is moderately high. So other different person have different perception. So we don't go with the qualitative judgment. We simply mention the value of r square. So it actually tells us the degree of predictive accuracy of our model. It gives a degree of predictive accuracy of our model, right? Means if mention here the degree of predictive accuracy is 90, means our model is able to correctly predict 90% of the observation. Then everything will be clear, right? So this is r square. I will explain one more concept, then I will show you the output. This value of r square is dependent upon two terms. It depends upon two things. Number one, number of independent variables or number of predictors, that is k. If k is large, then r square inflates. Okay, this is the first. Second is size of sample. Sample size n. If n is low, then r square inflates and vice versa, right? So r square has two weaknesses. One, right? One moment. Okay, so r square has two weaknesses, that it is dependent upon number of predictors and size of sample. So this r square is adjusted. This r square is adjusted with respect to size of sample and number of predictors. And accordingly, we have a better parameter that is known as adjusted r square. Every other thing remaining the same. So adjusted r square is also expressed as r bar square, right? So we can interpret through r square. We can also interpret through r bar square or adjusted r square, right? They both represent the same thing. But if we want to consider only one term, then obviously adjusted r square is a better representation of the strength of the model or degree of predictive accuracy. So we simply look for r square and adjusted r square. If an adjusted r square will always, because adjusted R square is actually R square minus adjustment factor. So adjusted R square will always be less than R square, right? So if this difference is small, then we can either consider R square or adjusted R square, things remaining the same. If this difference is large, then we have to consider adjusted R square in order to interpret the strength of the relationship. Okay, right? So before sharing you with the output, I am taking up and Dr. G. Ranita, I have explained adjusted R square. R square can never be greater than 1. Okay, because explained variation can never be more than total variation. Relationship between P and the hypothesis, right? If P value is low, suppose we are considering a significance level of 5%, right? So low means the P value is less than 0.05. So in that case, we reject our null hypothesis. No, our data, if data is not linear, we can't use the regression analysis in toto. We have to convert that in some linearity. Means either we can take logarithmic transformation or we can have square root transformation. Okay. Ramesh Shivali, your problem will be dealt afterward, right? Okay. Type 1 error and type 2 error, this will be covered when you will take up the testing part. Right? Okay. So any question related to regression, or should we share, I share the output part? Any related to this concept, R square, adjusted R square? Okay. So I am sharing you the output. Right. So here we have the output. Okay. Here, as you observe, the value of R square is 0.73 and adjusted R square is 0.722. There is not much difference between R square and adjusted R square. Why this is happening? Because we have a large sample size. We have a sample size of 300 and our independent variables are just 9. So they are not so high. So there is not much difference between R square or adjusted R square. So you can take either R square or adjusted R square, things remaining the same. Means here, if you take adjust R square, then you will tell that percentage of explained variation is 73%. If you take adjusted R square, then you will simply mention that percentage of explained variation is 72. So there is not much substantial difference between 72 and 73. So you can take either of the values. Since 72% or 73% represent a good or high predictive accuracy, then we can say that our model is performing quite good. Rule of thumb. Actually, there is no rule of thumb. If a rule of thumb is given in some book, then I think they are not doing justice with the statistics. That's why I am more interested in the value. Even in all the good research papers, if you consider ABDC or the high SCI index paper, they simply mention the values of R square. So for a particular person, suppose for myself, 73 means very high. For you, 73 is moderately high. So there's no thumb value. Yeah, right. We can apply a regression analysis on a sample size of 30 and 40, but there are a number of issues related to estimation. I will explain R. Interpret R. No, R square is not interpreted as percentage. This R is the correlation coefficient. This is a multiple correlation coefficient. R is simply the square root of R square. So if you do square rooting of R square, you will get 0.855. So this is simply the multiple correlation coefficient of this analysis. So R is also used to interpret the strength of the model. But why we don't interpret R? because R square cannot be interpreted on a base of 100. So we can't say that percentage of relationship is 85.5%. This is a wrong concept. Percentage can only be used in R square or adjusted R square. So that's why we simply say that 0.855 is very close to 1, means they are having a strong multiple correlation. Strength of the model is good, but that is not interpreted as a percentage. Be good adjustment factor. So the formula for the adjustment factor is you can have from any. I am sharing you the formula. So here the formula is adjusted R square is R square minus R is 1 minus R square divided by n minus k minus 1 divided by k. So this is the formula. You simply write R square is 0.73, means it is explaining the 73% of the variation. So it doesn't matter whether you are using R square for scientific paper or non-scientific paper. If R is 1, so R1 will happen when R square would be 1. So this is the extreme case. This is not happen in the real life. Okay. So Dr. Gaurav, that question will be taken up tomorrow when we move to the next step. So today I have taken up only the 2 steps. One is significance of the factors and the strength of the model. Okay. Since already we have 8:15. Okay.
So thank you so much, sir, for your patiently, giving the answers to our participants. And I hope the participants have enjoyed today's session. And we will continue tomorrow from onwards. So we will take the questions in tomorrow.
First we will take regression only, then we move to
Yes, then we
logistic.
will move for the logistic. So no problem. We will take some questions in the tomorrow session. Thank you all. And good night.
Okay. Thank you. Bye-bye. All the best.
Thank you, sir. Thank you so much, sir.